Welcome to another edition of Mr. Weis Solves an Old AP Problem. Today we're working on AP Calc BC 2008, number 5. So the setup for this problem is we're given some function f of x. We're not told what the function is, but we're told what the derivative of the function is, and apparently it's the quantity x minus 3 times e to the x. We're also told that f of 1 is 7. So part A says you can see that there is a critical number for f of x at x equals 3. So we clearly have a critical number at x equals 3 because f prime of 3 clearly equals 0. They're asking us to determine, is it a max, a min, or neither? Okay, so this is pretty straightforward. I honestly would probably use the first derivative test here. I think that students often sleep on the second derivative test, that it's actually a lot cooler than students give it credit for. That said, I'd really rather not take the derivative of this function. It will require a product rule and stuff, and I can quickly just do the first derivative test. So for the first derivative test, I'm going to draw a number line. Here's f prime of x. I can see that I have only one critical number for this thing because it always exists, f prime always exists, and it only equals 0 at 3 because e to the x is never 0. So if I plug in something bigger than 3, I'm clearly going to have a positive number, and if I plug in something smaller than 3, I'm clearly going to have a negative number. So thus, since f prime of x changes from negative to positive at x equals 3, we know that x equals 3 is a, let's see, it's decreasing and then decreasing is a relative min for f of x. I should say, rather than say is, I'm going to change this slightly. I don't think there's anything wrong. You'd probably be fine with saying ifs, but I'm going to say gives. I like to try to be as clear as I can about the difference between what the actual relative min is and that relative min's location. What we've found is the location of a relative min. I actually have no idea what the value of this min is. And I can't know that, in fact, at least right yet, because I don't know what f of x is. Okay, here we are doing part B of the 2008 number 5 AP Calculus BC exam. We're dealing with this function f of x whose derivative we know. We also know an initial value of this. Here's some of the work for part A. Part B says, are there any intervals from 0 and the domain of this function for which f is both decreasing and concave up? So we want to know, when is f both decreasing and concave up? So based on work that we did in part A, I already know that it's decreasing. This is when it's decreasing. So from negative infinity to 3, f of x is definitely decreasing. Now we just need to know if it's concave up. Sorry, they want concave up at any of these points. So in order to get that, I'm going to take the second derivative. So here we go. For the second derivative, I'm going to think of this as a product rule. I'm going to take these are my two functions, x minus 3 and e to the x. So the derivative, taking the derivative of the first, the derivative of x minus 3 is just 1. Leave the e to the x alone. Plus, leave the x minus 3 alone. Take the derivative of e to the x, which of course is just e to the x. This factors, I can pull out an e to the x out of this, and I will be left with 1 plus x minus 3. In other words, I'll have e to the x times x minus 2. So we find out, looking at this then, I see that there is one possible point of inflection for this function, one place where the second derivative equals 0, namely at x equals 2. So I'm now going to make a number line for the second derivative. X equals 2 is the only thing that's on here. And if I plug in something bigger than x equals 2, I'll get a positive number. If I plug in something less than x equals 2, I'll get a negative number. So we were looking for a place where the function is concave up and also decreasing. Here's where it's concave up. There's where it's decreasing. So I believe that the answer is, my answer is going to be this. On the interval, let's see, so 2 to 3. Now, you can include brackets or not on this. What's happening at 2 or 3, the AP doesn't actually care about, and nor do I, honestly. So on the interval 2 to 3, f of x is decreasing, since f prime of x is negative, and f of x is concave up, since f double prime of x is positive. Note that in all of my answers here, I'm being careful to say something about the sign of a derivative. All of my answers are going to say something about the sign of the derivative. Simply providing number lines is not enough. You need sentences where you say things about derivatives. Okay, here we are on the final part of the 2008 number 5 AP Calculus BC exam. And here's where we're finally going to use this information that they're giving us about this function, whose derivative we know, and whose we have an initial value that f of 1 equals 7. What it asks us to find for part C is it says find f of 3. So I'd like us to know the value of f at 3. I believe we already determined that this was a relative minimum for this function. We learned that in part A. But we're actually going to find the value now. So the key to this problem is realizing that using the fundamental theorem of calculus, essentially. Here's the big idea. The integral from 1 to 3 of f prime of x dx is, by the fundamental theorem of calculus, it would be the antiderivative of f with the plus c equaling 0. So there's many antiderivatives of f, but when we do the fundamental theorem, we choose the one where the plus c equals 0. We would plug into that antiderivative a 3 and a 1, and I should say actually, you can choose for your the thing you're going to plug in. We always choose the one where the plus c equals 0. Here, I'm actually choosing the one where the plus c is the correct value of plus c. So this actually is the honest-to-goodness antiderivative of f that we're interested in, the one that happens to go through the point f of 1, at one point where f of 1 equals 7. So just moving this f of 1 to the other side, we find out that f of 3, which is the thing we're looking for, is the integral from 1 to 3 of x minus 3 e to the x dx plus f of 1, which we know is 7. Okay, so we're left with finding this integral here. So I'm going to split this integral into two integrals. So this is going to be the integral from 1 to 3 of x e to the x dx minus 3 times the integral from 1 to 3 of e to the x dx plus 7. Now, this is just an example of some advanced integration techniques. At this point, you hopefully recognize that what was required to do this integral is a integration by parts. This is a fairly standard integration by parts problem. So what I'm going to do is let u equal x, dv equal e to the x, dx, then du equals dx, but v equals e to the x. So let's see, coming down then, this ends up becoming u times v, so x e to the x from 3 down to 1, minus the integral of v du, so that's from 1 to 3, so that's just e to the x dx. Then we still have minus 3 more of these things, minus 3 times the integral 1 to 3 e to the x dx plus 7. So just looking at these two things here, it appears that we have minus 4 of these things. So let's go ahead and just plug in what we see, everything that we have here. So I'm going to plug in a 3 and a 1 into the x e to the x and subtract. So I have 3 e to the 3 minus e. Now, this is minus 4 times the integral of e to the x from 1 to 3. But the antiderivative of e to the x is just e to the x. So this is really just going to be minus 4 times e to the x from 3 down to 1 plus 7. So let's see here. It looks like I have 3e cubed minus e minus 4 times e cubed minus e plus 7. So it looks like altogether here, I'm just going to bring this up for our final answer. Altogether, I have 4 e's minus 1 e, so we have 3 e's. And then we have 3 e cubes minus 4 more e cubes, so that's minus 1 e cubed plus 7. And this is f of 1.